Bell High School. It is Monday, February 27th, 2023. Will you please join me for a minute of silence? Thank you very much. Will you please stand as you are able for the pledge? I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you very much. Let's have a great day.
Alright, so we are going to continue section 3.2, which is what we started on last time I saw you guys, but it has been a while here. So last week was basically 3 B days and 1 A day, and then this week will be kind of the opposite. 3 A days, 2 B days, but one of the B days tomorrow is really the ACT, and you guys know that schedule's not really like a normal B day. So we are going to go through worksheet 1, 2, and 3 together this morning. So reviewing some logarithmic graph stuff, some logarithm properties, and make sure that you've highlighted what it is that you need to review. And then at the end of class here, I'll point out a few things I would look back over if I was you. But on the front of this is worksheet 1, and what I would like to do is start off by going over the first 12 with you as a quick little reminder, help highlight some of the properties that you're going to need to know, all that kind of stuff. And then I'm going to give you a minute to flip it over and try the same question types on worksheet 2, which is the back of this. And then if you're still missing them after we just went over them, then that would be your indicator. You need to come in, stop in during advisory, or just study those a little bit more, or something like that. Okay, so starting with number 1, since it is first, one property you certainly need to know with logarithms, the most important one that makes logarithms important, is when you have an exponent on something that you're taking the log of, that exponent can come down out front. There's actually a few times in mathematics where we bring it up instead of bringing it, or take it back up instead of bringing it down, but 99% of the time you're going to bring it down. And for this question, you need to remember how to read a logarithm. This is asking you 2 to what power gives you 2, which is of course 1, so your answer comes from 7 times 1. So that property of bringing the exponent down and knowing how to read an exponent. Now, instead of doing these in order, what I'd like to do is now go through and highlight all the questions 1 through 12 that use this exact same property. So number 2 doesn't look the same, it's going to work out differently, but number 3 is the same type of question because x is an exponent on something I'm taking the log of, so the x can come down out front. And then you need to know how to evaluate this the same way you need to know how to evaluate this. If natural logs bug you, or they feel less comfortable, remember just change it to log base e. This is saying e to what power gives you e, so that is 1 of course, so your answer comes from x times 1. So we're not solving an equation here, I'm not trying to figure out what x equals. Not all answers are going to be numerical, but same thing, bring the exponent down based on where it is, and then be able to evaluate the logarithm. Okay, and I think there's one more in questions 1 through 12. Number 11. 5 is an exponent on something that I'm taking the log of. So the 5 can come down out front. And then you're left with 5 times the log of 4 base 4, which would be 1. So the answer to that would be 5. You guys okay with those? Same thing a couple different times. Okay, so number 2 is a different property. So let's talk about what it is you need to remember with that. So in this one, this is the one, unfortunately, that you just don't get to use very much, but you got to recognize it to be able to use it in calculus. And this property says if you have a number whose exponent is log and the base is the same number of something, that all just simplifies to be the something. Again, I promise to show you why that works when we get closer to the test, if you would like me to. But these are easy questions, but you just have to make sure that you recognize the pattern. 3 to the log base 3 of 8 is just going to be 8. As long as that 3 and that 3 are the same, it doesn't matter. This comes up again in question 6, because this is e to the log base e of 5. So all of that's just going to simplify to 5. And I see one more. What's the other one in question 1 through 12 that's the same thing?
14. 1 through 12.
Yeah, just 1 through 12. Number 12. 10 to the log base 10 of 7, it's just going to be 7. Those are probably the easiest questions as far as amount of work. But if you don't recognize that pattern, if you don't recognize that property, then I guess you could miss a couple points. Okay, honestly, if you can do those two properties and evaluate like we did in 1, in 3, and 11, reading those, then most of the rest of questions 1 through 12 are going to be pretty easy. This is 5 times the natural log of e, so we've already even talked about this being 1 today, but you can change this to base e. So this is like 5 times 1. This is saying e to what power gives you 1? Should be 0. Anything to the 0 power gives you 1. Might as well do question 8, because 10 to the 0 gives you 1. Anything to the 0 power gives you 1. Number 4 and number 9 are basically the same thing. It's negative 2 times the natural log of e. Natural log of e is 1, so negative 2 times 1. Number 10 doesn't have the base written there, but as we mentioned in question 12, it's base 10 if it's not written. So 10 to what power gives you 10? So all of those you really just need to know how to read a logarithm. It's a little bit quicker if you know the natural log of e is 1, because you just use it so often, you don't want to have to think about it all the time, but you should be able to figure it out in a moment if need be. The one that I think is just a touch harder, because you do have to know and apply an exponent rule here, is number 7. After we do section 3.3, I can give you an option on how to work this one. If you guys remember expanding and condensing logarithms from Algebra 2, you can expand this and give yourself some options. But in the meantime, all you can really do, unless you remember that, a positive 2 exponent in the denominator is the same thing as a negative 2 exponent in the numerator. Most of the time in mathematics, we can take negative exponents and write them as positive, but sometimes we write them the other way. Now this is not really any different than question 1 or 3 or 11. We've got an exponent on something we're taking the log of. The exponent can come down. Natural log of e is just 1. Negative 2 times 1 gives us our answer. So because of that exponent rule, I'd say 7's the hardest one, and that's why I would put a star by it. But you should probably circle the ones that you think you would have missed without me talking about them up here. And then if you would do that, flip your page over and try questions 1 through 12, which are similar skills. So try these without a calculator, try them without flipping back and forth to see how you can do. Yes, ma'am.
I actually had a separate question.
Okay.
I was kind of wondering what makes you grade some quizzes as assessments and some quizzes as assignments.
I don't know. It just depends on what it is and how important it is. Me and Miss Thomas, she's the other pre-cal teacher, we just usually I don't know. We have to agree on those things. But like a section like 1.9 is usually, most quizzes are in the minor category. There's only been a couple this year that have made the major category. Like I remember section 5.3 we didn't test on, so that one counted as a major grade because it didn't have a test that would go along with it. But you're always welcome to ask beforehand if you think it's going to impact your grade a lot. But so let me give everybody a few minutes to try 1 through 12. I will share the answers and we can go over all of them if we need to, but I will let you tell me which ones you're most concerned about. Okay, let's wait. We'll just one more minute. Make sure everyone's had time.
If I go in there and get one of those big carts for Nancy to move.
You can, but you're gonna have to move the stuff off of them.
That's okay. Do you want it in any particular spot? Okay.
Just throw it on the floor. Doesn't matter to me.
Okay. I just checked it.
Okay. All right. So I'm gonna share the answers here, and then we can work them all out if we need to. But let's make sure these are right. We've got 5, 6A. Remember, your answer doesn't have to be a number. 2, 0, 2, -3, 2, -4, 0, 3, and 5. Now the nice thing is, if you did not learn logarithms very well last year, or if you just don't remember them at all, there's really only a couple things you need to know to be able to do those questions. So even if you're learning it from scratch, it's still pretty doable. Okay, any of those you want me to explain? The number 7, number 3. Okay, so since a is an exponent on something that I'm taking the log of, the a can come down out front. Are you okay with why natural log of e is 1?
Yeah.
Okay, so then it was a times 1. But again, we're not solving equations here, so it's not like you're trying to figure out what a is equal to. You're just trying to apply those properties. So same thing on the quiz. My B-Day class already took it because of how there were so many B-Days last week. And a couple of questions on the quiz, you should have X in your answer. But don't try to solve for X. It's just like this. Anybody else? Yeah.
Number 8.
Since there's not a base written here, this would be an understood base 10. This is a common log. So this is asking you 10 to what power gives you 100. So 10 squared. Did you put 10 there?
No.
Okay. Okay. Yeah, if there's no base, it's an understood base 10. So if that bugs you, just like natural log means base e, and you might want to rewrite it, if it bugs you that you don't see it, just always throw a 10 on there. But be careful not to accidentally multiply. Okay, back to worksheet 1. All right, let's do the next little section. So, I have not told you this yet because I didn't see y'all much last week, but we did decide to split up our major test into 2 parts, which I think is great news for you guys. So, right now we're focused on 3-2. We'll quiz on 3-2 next time, and then review on Friday, and then test. So you will have just a 50-point test over 1-9, 3-1, and 3-2. Then we'll come back and do 3-3 and 3-4 and do the other 50-point. So in the past, we have put it all together as one big unit, 100-point test, but it's a lot of information, so we're splitting it into 2 tests for you guys. So I think that should help. But when we get to section 3.4, which will not be until the second half of this unit, that we'll get into much deeper equation solving. But for now, there's really only 3 types of equations you need to solve. One's where they're like 13 and 14, where if you know how to simplify some of this, just like we did on the top of the page, log base 6 of 6 is 1, 7 to the log base 7 of 8 is 8. If you know how to simplify those, then you're left with something that's pretty easy to work with. Regular algebra 1 level problem left over. This one's a little bit harder, I guess, but 2 to the 3rd gives you 8. It's one that you can do in your head. So simply knowing this is 1, knowing this is 8, just like questions 1 through 12 is one thing we expect you to be able to do right now to solve equations. A second, which doesn't show up here, but switching forms. Sometimes you need to switch from exponential form to logarithmic form, or logarithmic form to exponential form. That was the first thing we looked at in your 3.2 notes part 2. And then finally, the last question type is when it's got logarithms in it, but it's already been balanced out. So like this side has natural log, but that side has natural log too. So those parts are already equal. So we just need to make sure that the inside parts are equal. Now, the one catch with solving equations that's a little bit of a pain is when we do this work, 6 might be my answer and 6 might be an extraneous answer. You actually have to plug it into the original equation and make sure that you are not taking the log of 0 and you're not taking the log of a negative number. That's how you get an extraneous answer. Your answer can be 0, your answer can be negative, but when you plug it in, if it makes the left side or the right side the log of 0 or the log of something negative, then it would not count. You would not want to include it. So you just have to be disciplined to force yourself to check that. But the good news is, if you do plug it in to make sure it's not extraneous, the left and the right side should be the same. So then you should feel 100% confident about your answer. So that is the same for 17 or 16 and 18. This is log base 2, but this is log base 2, so those two are already balanced out. We just need to make sure that the insides are equal and make sure that it's not extraneous. So divide both sides by 3. Plug it in. This would be log base 2 of 1/2 equals log base 2 of 1/2. So now I know that's correct. I'm 100% sure. And because it was not the log of 0 and not the log of a negative, it was not extraneous. If it was extraneous, we should not include it. Okay, we're going to skip 17 for just a second because that's the harder one in this little section. But over here, this is log base 10, this is log base 10. That's already balanced. We just need to make sure that the insides are balanced. So x would need to be 3. Plug it in. Make sure you're not taking the log of 0 or a negative, and you're not, so it is part of your solution. Excuse me. Okay, so before we go on to 17, are you guys okay with those? Okay, the problem with 17 is this is one that you can do in your head, but the answer is not a nice whole number. So when I look at this, I know my answer is bigger than 1 because 8 to the first is only 8 and I need it to be 16. I know my answer is less than 2 because 8 squared is 64 and I need it to be 16. So it doesn't take much effort to know my final answer somewhere between 1 and 2. And if it's between 1 and 2, that's a hint that it's a fraction / decimal. And you're welcome to do this in any way that makes sense to you, but what seems to work the best for students is to do this in 2 steps. I'm going to raise 8 to 1 power, make it become something else, and then I'm going to raise that to something to get it to 16. So I'm going to try to do it in 2 steps because doing it in 1 step is too hard. Now, I thought we had talked about this before, but my last class didn't seem to remember this. But you guys need to know that when you raise something to the 1/2, that's like the same as square rooting. Have you heard that before? If you cube something, or I'm sorry, if you want to cube root something, you raise it to the 1/3. If you want to 4th root something, you raise it to the 1/4. So over here, question 17, I would like to not take the square root of this. The square root of 8 doesn't come out to a nice whole number, but I could raise it to the 1/3 because what's the cube root of 8?
2.
Okay, so raising it to the 1/3 lowers the base down to 2, and now it's a whole lot easier to do. 2 to what power gives us 16? One more time? 4. Okay. Thought I heard it there. So what I want to do is I want to raise it to a 1/3 and I want to raise it to the 4th. So to do both would be raising it to the 4/3. Now if you can do that in your head in 1 step, that's great. More power to you, go for it. But I think if you break it down by raising it to the 1/2, the 1/3, the 1/4 for a square root, cube root, 4th root, whatever you need to do to make it lower the base, and then it's a lot easier to see. But then you want to do both at the same time, so multiply them to get your answer. Okay, probably a good idea to put a star by that one. I honestly don't remember if that's on the quiz or not, but that would be one that would be worth reviewing, I think. And then flip it over. And try those 6 questions in the same section, please. Okay, let's see how you did. So again, I'm happy to go more in detail on these, but I'm going to do kind of the quick version first. So 13 and 14, you needed to be able to evaluate this and this. This is 0, which gave you a final answer of a half. And this was 16, which gave you a final answer of 4, not 8. Don't do multiplication. And then 15, 16, and 18 were similar question types where they were both the same type of logarithm. So you should have set the insides equal to each other, solved, and you needed to plug them in. And if you plug in -6, you get the natural log of -12 is equal to the natural log of -12, which sounds okay, but you can't take the log of 0 and you can't take the log of a negative. So that does not work. There is no solution. You have to train yourself to consider that every single time. It's not that you're doing anything wrong, it's just that the process sometimes creates these fake answers. Okay, on 16, if this and this were equal, divide both sides by 5 and you get 1/15. Plug that in, it seems fine. Over here, 3x is 12, so x must be 4. Plug that in, that seems fine. And then 17 was the one that was a little bit harder. I would say raise 9 to the 1/2 makes it become 3. And then if I raise 3 to the 3rd, it becomes 27. So 3/2. Okay, of these 6, any of these you want me to go over slower in more detail or have specific questions about?
17.
Okay, so what I did on 17 was, like 17 on the other side, I knew the answer had to be bigger than 1, because 1 squared is only 9. I need it to be 27, or 9 to the first. I knew my answer had to be less than 2, because 9 squared is 81, which is way bigger than 27. So the fact that my answer is between 1 and 2 tells me that it was a fraction decimal, and it was going to need probably 2 steps. So instead of trying to do it all at once and make it even harder, I just thought about what could I raise 9 to maybe make it a smaller number. And I did a half because the square root of 9 becomes 3. And then that's good news because then 3 to the 3rd gives you 27. And then to raise it to the half and to the 3rd at the same time, you just multiply those, 3/2. I'm not saying that you have to do it in 2 steps, but it makes it a lot less mental juggling going on there. Is that enough? Okay. Anybody else for those 6? Okay. Yeah, go.
On 15, which negative number lets you know that it's no solution? Is it once you get -6 or once you check it?
No, your answers can be negative. There's nothing wrong with negative answers. It's when you check it, you go plug it into the original problem. Up here, if I plug it in, I would get the natural log of -12. If I plug it into the right side, I get the natural log of -12. But it does not make sense to take the log of 0 or a negative. And that's why we could not keep that as an answer. The only way I can kind of describe why natural log can't be, well, usually the easiest way is think about it visually. Natural log graphs look like this, regardless of the base, as long as you don't do any transformations. It never equals 0, and it certainly never equals -12 out here. It doesn't exist over there. This is like saying e to what power gives you -12. There's no, that doesn't make sense. There's no number, no exponent on e that gives you -12. Okay, then let's move on to the last section. Do that and do some guided practice on the back, the same type of question, and then we'll move on to worksheet 3, and I'll remind you what you should look over between now and Wednesday for the quiz. Okay, the bottom of this is all about graphing stuff, and the big key to graphing, like we did in the part 1 of the notes, is understanding this relationship between exponential functions and logarithmic functions. 2 to the x is inverses with log base 2 to the x. That is supposed to help you, because if I have to graph this question for number 20 and answer a bunch of stuff about this graph, I'm going to start off with 2 to the x. So 2 to the 0, 2 to the first, 2 squared, 2 to the third, exponential growth. That's why we did 3.1. And then the fact that I know that this is inverses with log base 2 to the x. This is why we did section 1.9 recently. Inverse just means you switch x and y. 0, 1 becomes 1, 0. 1, 2 becomes 2, 1. 2, 4, 4, 2, 3, 8, 8, 3, etc. That's how I know what log base 2 of x looks like, and I know a few exact points on it without much effort. I know all logarithm graphs look like this, but it's nice to have a few specific points. Then all you have to do is use your transformation rules. So if we're adding 4 to x, that's going to be left 4. So move all of these points that I was sure about left 4. 1, 2, 3, 4. The whole graph moves left 4, and because I've got more than one graph on my thing, I need to label which one is which. But now I have figured out which one they want me to look at to answer all these questions. Now I can confidently say the domain approaches -4 on the right and infinity, or on the left, and infinity on the right. The range, he goes down forever and up forever. Now he does, granted he does go up slowly, but he does go up forever. If you keep going to the right, it does keep going up. The asymptote is right here. An asymptote is just a line that the graph approaches but can't cross. Since this is a vertical line, it's x equals instead of y equals. Because I was careful with some points, I can see the x-intercept, and I feel confident in that. Because I was careful with some points, I see the y-intercept, and I'm confident on that. And even 4, looks like 4, 3 is also good too. Looks like I had that exact point also. But keep in mind, I will admit, last week in B-Day, like I wasn't sure about a couple of these points. I just made my graph a little bit too fast. I wasn't confident in these last two. But you guys need to know that you don't just have to cross your fingers and hope that you're right. You can also check this algebraically. If you're willing to plug in 0 for x, solve this. Log base 2 of 4 would be 2. If you're not sure about this one, plug in 4 for x, solve for y. Log base 2 of 8 would be 3. And if you're willing to do that, it might help you catch some mistakes on your graph. If you accidentally went right 4 instead of left 4 or something, then those points wouldn't be on your graph and you would know something was off. So very easy to just plug the x values in and solve for y. I mean, maybe not if you're doing x equals 1, because that's not going to be a whole number, but all of these points that I think are whole numbers I can check by plugging in. I don't just have to rely on my graph. Okay, but the most important part here, you guys have had lots of experience answering these question types in the past, but to graph this, if you're looking at the wrong graph, you're answering all of these to a different graph. You might get a few of them accidentally, but you're going to miss some of them. I graphed 2 to the x so that I could switch the points, switch x and y to get its inverse, and then comparing this to what I actually wanted to graph, I just used the transformation rule of left 4. So mark what you need to mark, flip it over, and then try those 2 more to see if you can get them right before I share the answers with you. Yeah.
Why would there be a bracket by -4 for the domain?
Why would there not be?
Yes.
Because it doesn't ever reach -4. It just gets close to -4, but it doesn't reach it.
Okay.
Brackets when you want to include it. Parentheses is just when you approach it.
Okay, thank you.
Looks like we need maybe one more minute to give everybody a chance to cut up. Okay. So let's look at this. And again, I'm probably going to go a little bit quicker here, but I certainly don't mind going over the ones y'all need to. So question 19 and 20 are not directly related on this one, but you should know that if 2 to the x is inverses with log base 2 to the x, then 3 to the x is inverse with log base 3 to the x. Now question 20 was a log base 2, not a log base 3. So I personally would start off with 2 to the x again, just like I did on the other side. Graph it. Still a few of his points. Switch x and y to get his inverse. Which is log base 2 to the x. And then I can just worry about transformation rules. Left 8, so I've got like 4 points here that I'm sure about. Shift them all left 8. Everything moves right or left 8, including the vertical asymptote. So if it was at x equals 0, now it's at x equals -8. And then I believe that's what I should be looking at. So he approaches -8 on the left and infinity on the right. Goes down forever, up forever. The line that he approaches that he can't cross is x equals -8. It's a vertical line, that's why it's x equals, not y equals. I believe when x is -7, y is 0. Pretty sure about that point. The y-intercept is when x is 0, and I think that's 3. But because it only takes me 2 seconds to check it algebraically, plug in 0 for x and solve. Log base 2 of 8 is 3, so I'm sure that is correct, and I'm sure that's a point on the graph. And then same thing with x equals -4. I think it should be 2, but I can plug it in algebraically and know for sure. Log base 2 of 4 would be 2. That helps me feel more confident about my graph as well. Okay, any parts of 20 that you'd like to ask about or would like me to go over again?
When it's a test question,
Uh-huh.
do you keep the graphs that we transformed from?
It's up to you. The only thing that I would have to dock you points for is if you do this. If you give me 3 graphs and you don't tell me which one's your answer, I can't assume that the correct one's your answer. Like, I'm pretty confident that you must know which one's the right answer, but I can't assume that for you. So if you want to have multiple graphs down, you just need to make sure you label them. Like this guy's just 2 to the x, this guy's just log base 2 to the x, this guy is log base 2 to the x plus 8, or f of x is what they called him. Or you can just erase so that there's no doubt. But just don't give me multiple lines and then think that I can assume that for you. I can't guess what your answer is. But otherwise it doesn't matter. Okay, let's finish up then with worksheet 3. So some of the same stuff, reinforcing some of the more commonly overlooked things, but also reviewing those transformation rules and specifically the y-axis reflections. Now on worksheet 3, I actually would like to do this one backwards. I think it makes sense to start off with 3, where we just review the transformation rules, then we apply those to graph them in number 2, and then we can see how that helps us with question 1. Okay, so transformation rules. If you add directly to x, that is when it goes left that much. If you add outside of the parent function, it goes up that much. If you multiply the parent function by a negative, that's how you reflect over the x-axis, or flip over the x-axis. Really, you shouldn't use the word flip, because flip is not a transformation. I know that's like the action you think of, but reflection is the math, a real math term. Over here, it was just that. Just reflecting over the x-axis. But if you multiply the x only by negative, not the whole parent function, that's how you reflect over the y-axis. These are the two that you guys get mixed up too often. X and y. X is the one that happens a lot, y is not as common, but you do need to recognize that transformation. Okay, so let's go backtrack to question 2. The directions say find the intercept as well. We're not going to do that. We're just going to worry about the graphs. If you can get the graphs, you should be able to get the intercepts. We just practiced that on the other one. But all of these graphs talk about log base 3 of x, so I really only have to go through these first couple steps again, or one time. But if I know what 3 to the x looks like, switch x and y, and that's how you should know what log base 3 to the x looks like. And all of these questions say log base 3 of x, so let's just go ahead and graph that, and then we'll worry about the transformations. So 2 is not too different than 3, whereas 3 is you're just describing the transformation. Question 2, you're actually performing the transformation. So you should be able to look at this and see that that would be left 3. So if you can graph the step before, you can certainly graph this. Move all the points you're sure about left 3, reconnect them, make sure the whole thing's moved left 3. And then I've got more than one graph on my page, so I should either label my answer or erase the previous stuff. Okay, for B, this reflects over the x-axis. So a point on the x-axis will stay on the x-axis, but any other point flips over to the other side. Make sure you label which one's your answer. Skip C for just a second because that's the one I'm most worried about. This is really why I think this handout's necessary. But plus 3, that's not directly on x, so notice these parentheses make a big difference. This parentheses tells me, hey, you need to add 3 to x before you take the log. Down here, it's being added after, so that would be up 3. So move the points you were sure about, reconnect them, make sure that he has looked like he has been shifted up 3 before you call it your answer. Now, The reason I'm concerned about C is because this is the one that I said I don't think you guys see in Algebra too much. I tried to emphasize this for you in your notes, but with the long break in class, I guess that makes it a little bit harder too. This is going to reflect it over the y-axis. This is a positive 3, which normally means left 3. But when you flip something over the y-axis, the rules for left and right transformations are opposite. So this is actually like right 3. The reason why it works this way, and I do think it helps if you write it this way. Well, first off, we can switch these. Positive 3 minus x is the same thing as the negative x plus a 3. The negative, even though it looks like it just goes to the x, it actually doesn't. The negative goes to the x and a minus 3. That's why this is right 3, and it's not what you're used to. When you flip over the y-axis, your left and right transformation rules are backwards from what you expect. Now, you won't have the quiz on the test, or a calculator on the quiz, but you're welcome to graph that if you have one with you today, if you want verification. So I could flip this guy over the y-axis. And then go right 3. So it's not like your quiz and your test is going to have a ton of points assigned to that, but we usually do have a few. So that would be a good one to review, since I don't think you learned that in Algebra 2. Okay, and then all of that being said, is everybody okay with 2? We can move on. Okay. Question 1 doesn't say you have to make a detailed graph or anything, but it's sure going to help if you give yourself a little bit of a sketch, because when we have a sketch of the graph or a full graph, answering these questions are just extracting it from the graph. So when I look at this mess, I would say, well, natural log is just log base e. All natural log graphs look like this before transformations. Because of the negative on the x, that's going to flip it over the y-axis. And then the one I'm most worried about is this positive 1 is like adding 1 to x, which normally goes left 1. But because we reflect it over the y-axis, it actually goes right 1. So his asymptote went from x equals 0 to x equals 0. Then right 1 makes it go to x equals 1. He approaches negative infinity on the left, and he approaches 1 on the right. But if you don't go the right direction there, then you're not going to get either one of those points right. And that's the same thing we just talked about in 2C. So just one more example. Okay, so we will, this is the last thing I've got for you guys today. So y'all got about 20 minutes. But before you put your stuff up, I would mark which things would be beneficial to look back at. The most important would be 88, the first handout we looked at today. It's the one that's closest to what your quiz looks like. Your quiz doesn't look exactly like that, but that would be the closest one. So I would feel confident about the question types and properties on number 88. But it would also help to look at 86, the first time we talked about graphing. 87, where we took some notes over the properties. A lot of that should be repeat. And then 89, which was worksheet 3 that we just went over, has a couple extra practice on some of the harder stuff that I think would be beneficial to look at as well. I will be asking for 2 of these for some participation grades. I know we did all of these together, but I need to give you some homework points. Those are opened up in Google Classroom already if you want to turn them in now. Otherwise, please make sure you have them with your name on them ready to hand in before we start the quiz on Wednesday. So that's the last thing I've got for you, but if you know that you're going to need to do some studying, you got 20 minutes right now that you could put it in it. And then if you came up with any questions, I'd be happy to help. But especially with, I assume some of you guys are doing the ACT tomorrow. Honestly, don't know how many juniors we have in here. Usually pre-cal is mostly juniors. Yeah, quite a few of you. So, I suspect you'll see a couple logarithm questions on the ACT, usually on there. So hopefully, even if you could have gotten them right before today, hopefully you can work them a little bit quicker based on what we talked about. So Wednesday we'll quiz. Friday we'll go over the 1.9, 3.1, and 3.2 quizzes to review. And then this time next week we will have the first half of this unit test.